In this video, we're continuing section 2.1 on rectangular coordinates, and we're talking about how we can find the midpoint between 2 points, the distance between 2 points, and the slope of a line connecting 2 points. Okay, so let's get into an example. So I have these 2 points, P1 and P2, and I first want to find the distance between those 2 points. Okay, so I'm going to draw a picture. Then I'll talk about a formula for distance. Okay, so let me put some tick marks. So I will go 1, 2, 3, 4, 5. In the negative direction, -1, 2, 3, 4, 5. That's -5. That is +5. In the y direction, 1, 2, 3, 4, 5. I'm noticing that my tick marks, my points y values go up till 7. So I'll go 6, 7 here. And then negative y direction, -1, 2, 3, 4. Let's go one more, 5, -5. All right, so let's plot the points. P1 is at -3, comma 2. So -3, comma 2, that is where the first point P1 is. And the second point, P2, is at 1, comma 7. So 1, comma 7, that would be over here. So I'm interested in finding the distance between those 2 points. So I'll draw a straight line connecting them, and I'll call that distance capital D. Okay, so I want to find that distance. Okay, so there is a formula to get the distance between 2 points, but I want to motivate where it comes from. Okay, so I'm going to draw a separate picture for this to talk about that formula. So let's say I got some axes, and one of my points is x1, comma y1. And my second point, its coordinates are x2, comma y2. And I want to find the distance between them. So if I draw a straight line connecting them, how long is that? What I'm going to do to help me with this is draw a couple of extra lines to make a right triangle. From the bottom point, I'm going to draw a horizontal line until I get right below the second point. Okay, and then from the top point, now I'll draw a vertical line straight down until I reach that horizontal line. When I do that, it creates a right angle. Okay, so now let me write down the sides of this right angle. Okay, so to get this length here, I got to subtract the two x values. I got to do the bigger x value minus the smaller one. Well, in my picture, x2 is the bigger x value, minus the smaller one is x1. Okay, so that's going to be the horizontal length. Similarly, this vertical length is going to be the y value subtracted. So the bigger y value in my picture is y2, minus the smaller y value in my picture is y1. Okay, so if I call that distance of this hypotenuse d, I'm trying to find d. If I use Pythagorean theorem, we'll get one of the legs, which is x2 minus x1, being squared, plus the other leg, y2 minus y1, being squared, equals the hypotenuse, which is d, being squared. Okay, so if I want d, if I want that distance, I just square root both sides. So d, that distance, is going to be the square root of x2 minus x1 squared plus y2 minus y1 squared. And remember, I cannot just distribute the square root to each of these terms because these terms are being added. So there's nothing here that would cancel. Okay, so that is the general distance formula. But I wanted highlight mode. But it just comes from Pythagorean theorem. Just comes from the Pythagorean theorem that we know and love. Okay, all right. So let's apply this to our example. So in our example, let's compute the distance. We got the distance, and my distance will be a big old square root. Let me write down the distance formula. x2 minus x1 squared plus y2 minus y1 squared. And if I plug in my coordinates into this, I'll get distance equals, okay, so x2 minus x1. So for x2, I will plug in 1, and then minus for x1, the other x1 is -3, -1 minus -3. That's going to be squared plus, and now in the other one, I just got to stay consistent with the order. So if I put 1 first in the first parentheses, then in the second parentheses, I should put its y coordinate first, which is 7. minus the other y-coordinate is 2. All right. Okay, square root of this whole thing. So simplifying this, I get d equals 1 minus negative 3 is 4. So I get 4 squared, and then plus 5 squared, square rooted. And simplifying this, I'll get square root of 41. And there's no perfect squares that divide 41. That's as far as I can take it. That is my distance. I could also see the Pythagorean theorem coming into play here. If I were to draw some lines, not that I have to, the distance formula did the trick, but if I were to draw these horizontal and vertical lines to make a right triangle, and I think about those legs, well, the distance in the x direction is going to be 4 units, and the distance in the y direction, from when y is 2 to when y is 7, is 5. And notice those are the numbers that were showing up over here, 4 and 5. Okay, so this did boil down to the Pythagorean theorem. Okay, so that was the distance between 2 points. Part B, how do I get the midpoint? How do I get the midpoint of the 2 points? Okay, so I'm going to call let me put it in a different color. So the midpoint is the point exactly halfway between the 2 points. To get the midpoint, I average the x values first, x1 plus x2 divided by 2, comma, and that's going to be the x coordinate. Then I average the y values, y1 plus y2 divided by 2. Okay, so let's just plug in. Let's just plug in here. So my x values, one of them is negative 3. One of them is 1. I'm going to add them together and divide by 2. Comma, I'll do the same thing for the y's. One of the y values is 2. One of them is 7. I add them together and divide by 2. Okay, and if I simplify, first fraction is negative 2 over 2. That's negative 1. Comma, the next fraction is 9 halves. All right, so we got our midpoint, negative 1, comma 9 halves. So my picture, if I were to draw that, negative 1 is here. And at negative 1, my picture is not perfect, but that looks like about here-ish. That would be negative 1, comma 9 halves, my midpoint. All right, final thing I want to get here is how do I get the slope of the line connecting 2 points? So I got to remember my slope formula. My formula for slope. Remember, we call the slope m. And the slope formula, it's my rise over my run. And actually, I've already figured out what the rise is and what the run is. But let's just, for practice, say I didn't know what those were. What's our formula for slope? It's the change in y2 minus y1, over the change in x, x2 minus x1. Okay, and I'm going to plug into this. And it doesn't matter the order that I plug into this, as long as what I do on the top, I stay consistent on the bottom. So maybe for y2, I'll pick the y coordinate over here. Maybe I'll pick 2 first. Okay, and then minus the other y value, which was, 7. Then I got to stay consistent on the bottom. So first I got to put the x value that went with 2, which was negative 3, minus the x value that went with 7, which was 1. All right, simplify. So we got negative 5 on the top and negative 4 on the bottom. The double negatives cancel, and I get positive 5 over 4. And if I look up to my picture, well, that's what we were getting for the rise, 5, and for the run, 4. So it makes sense that the slope should be 5 over 4. All right, so that is our answer. So in the next section, we will review equations of lines. And for that, we will need to be able to get the slope of a line.